I don't think this amp was designed for 6L6s in mind. So you've got a tiny little EZ81 rectifier valve there, and it's cathode bias. So when you're running this thing at 95%, which it should be being cathode biased, you're pulling like almost 60 watts of juice there just idling, and that poor little rectifier was sagging quite a bit. I tested the output power with 6L6s, and we were just approaching 18 watts, sorry, into 8 ohms, and that was maximum output was at 8 ohms. So I put some 6V6s in there. They biased up nicely to 14 watts, so above maximum, but pretty happy there. That's what you find in a lot of the Fenders and stuff. I could tone it back a bit, but I'd have to order another resistor there, or parallel some that I've already got. And it's still putting out 18 watts, but it's only consuming about half of what it was before to try and approach that 95% dissipation on the output stage. So everything's a lot happier. It already gets pretty hot in the cabinet, this thing, so any power consumption savings we can do would be great, especially with that tiny little rectifier. So moving our way along, I've put strain relief on the speaker output as well. He didn't want a jack installed, he just wanted the stock cord to try and keep it original, but again, there was no strain relief at all. You could yank on that, and that's your screen dropper there. So curious position for it, but I guess they've gone to the B+ in the center tap of the output transformer, and then they've just found that as a convenient place to put the dropper there, and then that feeds the output valves and then carries on to the next node. Phase inverter. I fire the thing up. We're just sorting out a few remaining gremlins. I've already put like probably 12 hours into this thing. That's the problem with vintage amps. You kind of can't charge the normal hourly rate, otherwise every repair would start at about $1,200 once you've sorted out all the bullshit and the silly design stuff and the old dumb way of doing things that you can't do anymore because you can't get the parts for it, or form factor issues. So you end up spending like the majority of sort of 2 days on them. The only way you can not charge for that is if you can do it at your own leisure. So if you've got a customer that's ringing you up, oh, is it ready, is it ready, is it ready? It's like, well, okay, it's going to cost you $2,000 then, mate. Otherwise, you're going to have to be patient. So over here I found, not saying that's the case with this customer, but it does happen on some of these sort of more drawn out restoration jobs. So I found this resistor here, the tail resistor in the long tail pair phase inverter was noisy. I tried swapping out a bunch of valves first, easy thing first, and see if any of that could stop it. Pulling the phase inverter indeed stopped it, but pulling anything before it didn't. It's got this pot here to balance I'll show you on the schematic in a minute, but that's basically your that pot there is the plate load resistors for the phase inverter, and it's like a balance control. I thought maybe that was causing it. There was obviously DC on it, so there was quite a bit of noise when you moved that shaft. So I substituted that with 2 metal film, just 100 Ks, to supply the plates for the phase inverter, and that didn't eliminate it. So I'll probably not use that pot though. Having, phase inverter, what is it? It's in the order of 200 odd volts on the pot there. It's probably not a great idea. So yeah, I established that it was that tail resistor there, so I subbed one in, but I've just removed that to show you the effect that it was having, so I'll show you that in a second. So we're plugged into the test cab. I'll just flick it on. You can hear a bit of buzz there from the transformer. You have to check that its laminations are nice and tight. So we've dropped down to 40 watts, and it's rising as the valves start to conduct. And we're stabilizing at about 80 watts. Fuckwits with loud motorcycles. I know, because I'm one of them. So you can hear there the crackling sort of thunderstormy noises happening, as if you're listening to a AM radio on a stormy day. That is that tail resistor in the phase inverter. So let's just lift a leg on that one. Lift a leg. Don't let anyone say this amp's not worth pissing on. Kind of hard to get in there with all the leads everywhere. So just lift the leg on that one. We'll put our metal film one on, just temporarily tack solder it. Just to demonstrate that that's the problem. Sometimes that's the quickest way of determining what the issue is, if it doesn't reveal itself easily with measurements. Alright, so we'll just fire it up with that new tail resistor. Temporarily installed. I'm starting to conduct across the output transformer. Now we've got a bit of hiss there. A little bit of buzz because we haven't got a balanced heater supply, which I'm also going to do. That's yet another thing that we can improve rather easily, but they all build up, cost and time wise. But there's none of that AM radio during a thunderstorm sounding crackling. So that's the tail resistor sorted. So we'll install that permanently and move on to the next problem. Now this came stock with a cathode resistor for the output valves at 25 microfarad 25 volt. In its operating condition where we're approaching 100% dissipation on the output, we were having a potential difference of about 30 volts across that, so above the rating of the cap. So I've upped that to a 50 ohm. Alright, so this is up the reverb end of the preamp side of the chassis. That cap I've subbed in. It came with some local filtering in the form of this cap, 470 nano, 160 volts, but we were pulling about 240 volts across that, so that's not good. So I got rid of that and put a 1 microfarad film cap in there, 630 volt rated. That's just temporarily mounted just to confirm that it sorted the issue. Working our way up, we've got new bypass caps, one there, one there. I think the LDR is a bit weak. It's not really giving a good depth in the vibrato. The neon is triggering, however. More bypass caps, bypass caps, bypass caps. Now, unfortunately, of course, that epoxy potted secret squirrel tone stack block wasn't passing signal, so there's something had gone wrong in there, but I had to destructively disassemble it to find out what it was, and it was basically a backsandal tone stack. So I've recreated that directly on the pot terminals here, and we might play with some values there, but that's a matter of taste. We've pretty well recreated what was in that block value wise, and the customer's familiar with the amp, so I might just get him to play it first, warm up to it, and then we'll maybe go from there, any modifications. The 2 volume pots are J-taper, and the customer and I agree that you get a pretty abrupt increase in volume up to say 3, but then sort of nothing happens till you get to 9, and then it's a very abrupt increase to overdrive. So I suggested maybe we might change them out with some different pots, different branded pots. I've got some CTS so we can retain those switches, which is the bright cap, with switches in a bright cap for each channel, and that might make it a bit more intuitive to adjust. So the next thing is there's some oscillation happening in the first stage when you turn the volume right up in certain settings, exacerbated by the EQ being turned to be brighter. So what I might do, grounding the grid on the input stages stopped it. So I might move the grid stoppers directly to the valve socket, or maybe introduce another resistor there, like a 10K, see if that damps it. The jacks are okay there, performing okay after a clean. You can see there's quite a bit of wear there on those contacts though, so if they keep being used it probably won't be a problem, but if that's worn through the plating and it's let to sit, they could corrode and then become pretty crackly in the future. I've got to put some lock washers on there as well, because that's your main ground connection for your input. So there was some wire dress changes here as well, some lead dress changes. I tucked a lot of the HT down the bottom there, but again that being rearranged could maybe address our oscillation issues as well. we're gonna have to have a poke and a play, and this is where the vintage amps, particularly when they're not that well designed, are really time consuming. You're basically re-engineering something that's already built and sort of works, like it makes noise, but it's not the world's best amp by any means. And we're not trying to make it the world's best amp, we're just trying to make it stable, and sometimes even that's a challenge in amplifiers like this. So, well, we've got it up, we've got nothing plugged in, so all the inputs are shorted to ground. I'll just, that's the lead channel volume. As we crank it up, just starting to oscillate, and it goes up in pitch, probably into supersonics as you turn it up. On the rhythm channel, which is the only difference between the two, which I'll show you shortly, is the coupling cap on the output of the first stage. Otherwise the two channels are identical, and the lead channel is the only one that gets fed to the reverb. So on the rhythm channel, cranking that right up, no oscillation. Now, another reason the transformer's physically buzzing, it's probably because it's only secured by those rivets there, which is a very silly idea for a transformer. Don't use rivets on a transformer. They've held on for this many years, but this has probably had a very easy life. If it was on the road, that transformer would have fallen off years ago. And the same over here for the output transformer. So yet another job we've got to do, probably another half hour in drilling them out and cleaning it up and drilling to suit a screw and fitting all the hardware and washers and lock washers and nylock nuts and all of that. And all of these little jobs they build up. That's why these amps, if you want to do them properly and make them really resilient, it's multiple days pretty much of full work. There's other techs that'll laugh at that and go, "Oh, you're so slow." Yeah, well, you probably just changed the caps and didn't look at anything else, and you probably gave them back a substandard amplifier. So, you know, it's one of those things. That's why people come here, but it's also why I don't make a hell of a lot of money doing this, to be honest. So back to the lead channel, and crank that up again till it oscillates. And we can manipulate it by changing the treble control. And the bass control doesn't really touch it until you get to the bottom end of it. So that increases it. As we increase the treble, it makes it easier to oscillate and the frequency goes up. So turning the treble down, we can get it to a point where it stops oscillating, and that's at about 10 o'clock or something. And then you can hear the hum increase there, and you think the oscillation stopped, but there's a bit of hum increased, and that is showing that dissipation as well. So that means it's still oscillating, you just can't hear it, it's above your hearing range. Now mind you, all these you know, fault modes, I guess you could call them, fault modes, occurring at pretty extreme settings, where the amp's probably not going to find itself set to most of the time. However, it's pretty easy for a tech to just say, "Oh yeah, but just don't do that." And I've heard that from a lot of other techs and other customers that have ended up here from other techs. "Oh, you're just setting it wrong." No, that's incorrect. So you should be able to set, you know, maybe not mess the boogies in their stock form, but you should be able to set a well-designed amp. Well, there's your caveat: well-designed amp. Mess the boogie does not apply. You should be able to set an amp to any setting pretty much and not have it oscillate, right? You should be able to set it to any setting and not have it flab and fart out and do horrible blocking distortion and hum and hiss and buzz. A well-designed amp should be able to be operated by a complete idiot and not hurt anything or have any weird behavior that could hurt things. Oscillation can lead to like red plating and that kind of thing, like massive dissipation of the output stage constantly without the owner being aware of it. So yeah, basically amps should be idiot proof. You shouldn't be able to set them in such a way that they can cause this kind of drama. So, well, it is a shame that we can't use, well, we can use, but we shouldn't use the original mini watt 6L6s that were supplied with the amp. I really think 6v6s are a much better suit to this amp, and will perform a lot better, generate less heat, use less energy, and stress the power supply a lot less, so it makes sense. Otherwise, all the other valves in the amp are performing reasonably well. No real weird noises or hiss or hum or anything. And I've cranked it right up, and everything's sounding pretty nice until it runs away. So there is some weird decisions with the tone stack and the couplers and that kind of thing. But again, I wasn't commissioned to change the character of the amp, just make it really reliable and get rid of all the quirks, a lot of which weren't reported by the customer. So either he didn't know they were there, or he forgot to tell me, or something. So there's the new pair of Tatties, 6v6 GTs. Tube amp Doctor are my preferred valve pretty much across the board at the moment. I've got some older stock of JJs which are still good, and Electro Harmonics that I bought before they all went to shit. But for new stuff, Tube amp Doctor's the way to go. But you know, tube manufacturers, valve manufacturers, that applies only to this month. Next month it could completely change. The rectifier valve's okay, and you can see whoever wrote it there didn't know the type of valve because it was rubbed off, but that's a 6BM8 triode and pentode combinationage. Oh god, 6AV6, 6AV6, they're fine, and two 12AX7s and a 12AX7 phase inverter there as well, and they're all performing okay. Alright champions, I've addressed the weak tremolo, but the problem is this new LDR is a different off resistance, different dark resistance to the old one. The old one was about 1 meg, this one's only about 150k, so I've got to wait for the other one to come in because it's not something I've got in stock, and that will give it a more even adjustment range. At the moment, when the depth knob is all the way up, it's full depth, and then about there it cuts to nothing. So all your depth controls between there and there. If we have the proper value LDR, light dependent resistor, we'll have a more gradual adjustment over the range of the pot. So I'll just have a quick play with that, show you what I'm talking about. You can see there's maxed out. And there's about 90%, and it's already gone away. But the effect is much stronger than it was with the old one, and the old one just looked physically like the tracks on the sensor element were faded, so it's probably just degraded chemically, and it's definitely a lot stronger in effect with this one. It's just the range is out, so I'm probably going to give it back to the customer like this, and we can fine tune it at another date, and I can order the parts in the meantime. He can play it and warm to it and just get used to it and bring up any other concerns to really dial this one in how he likes it at a later date. So here it is with the phase inverter balance pot removed. I've put a tag strip in there. It's just a bit safer, a bit more sturdy, and we're not relying on the voltage rating of that pot, because you've got your DC there, yeah, fair enough, but you've also got the signal riding on top, and that can reach peaks, pretty crazy peaks that may arc over within that pot. So you've also got the carbon track element, which adds a fair bit of noise, and it was adding a fair bit of hiss and crackling, particularly when you move the shaft. And while I was in the area, I chucked some flyback diodes on the output sockets as well, just to be safe. So still not ready to send back to the customer yet. This thing's just never ending. Transformer's loose. Got to drill out those rivets. The transformer's mounted with friggin' rivets through washers, which is ridiculous. So I've got this monster drill. This is an aircraft drill designed for this purpose, drilling out rivets. And that allows us to get down in there. Not not going to do it holding the camera, but that allows us to get down there, drill the rivet heads out without having to remove any parts to access it, and you know, the thread of the drill chuck sort of scuffing the transformer casing already more than it already is. Alright, now we've got some proper M4 machine screws with a flat washer on the top, and on the other side we've got lock washers and nylock nuts instead of stupid rivets in stupid washers in a stupid chassis. So in the process of doing that, also tightened up the lamination bolts there, so we'll probably find, this is the output transformer, power transformers over here, but we'll probably find that audible buzz coming from the transformers greatly reduced or gone completely now. Well, tightening those transformer lamination bolts actually worked a bit better than expected. I turned it on then and almost had to look twice. It didn't sound like it was even turned on. Went looking at the power meter on the wall just to confirm that everything was drawing current. So here we go. You can barely hear the slightest of hum unless the camera is picking it up inductively, but you got to hold your ear real close to even hear anything. So success. And while we're rebuilding the whole bloody amp, I thought I'll chuck two rubber grommets on the chassis there just to prevent cutting through that signal line there. That's from the output of the preamp to the input of the phase inverter, which is there. It's pretty loud, eh? It's 18 watts, so it's not stupid loud. This thing is so quiet now. Well, you know, quiet until you want it to be loud. The last thing I did was heater balancing. So I lifted the center tap of the heater and put 200 ohm half watt fusible resistors to ground in that same spot where the center tap used to be, and that really killed the last of the noise. So there you have it for realsies this time, champs. I'll see you on the next one. This thing's been a bit of a nightmare, like all these restoration jobs. I'm starting to think I've got to stop taking them because they just clog you up by several days, and it's just utter disaster here after that. And everyone thinks I'm the worst person in the world. So thanks for that. Anyway, see you on the next one. Take it squeezy.